Right, let's look at just a revision on calculating of molar mass, calculating of the conversions between mass to mole and mole to mass. So we'll start with calculating molar mass. I'm going to start by looking at copper sulfate. Now if you want to calculate the molar mass of copper sulfate, you're going to need to go to your periodic table so that you can look up the molar masses of three elements: the element copper, the element sulfur, and the element oxygen. So we'll write those molar masses down. We see that when we go to periodic table, copper has a molar mass of 63.55 grams per mole, because the periodic table tells you how many grams of copper will you find in 1 mole of the copper. And that's the same for every element on the periodic table. The value given is the mass for 1 mole of that substance. For sulfur, we see that that mass is 32.07 grams per mole. And when we look at oxygen, we see that it is 16.00 grams per mole. So these are the masses of 1 mole of each of these substances. In my formula, I can see that I have 1 mole of copper, I have 1 mole of sulfur, but I have 4 moles of oxygen. So therefore, when I add them together to get the relative atomic mass, I'm going to take 1 copper, which is 63.55 grams. I'm going to add it to 1 mole of sulfur, which is 32.07 grams. And I'm going to add that to 4 times 16, because I have 4 oxygens. I simply add all my masses together to get a grand total of 159.62 grams per mole. Now you need to understand this, that the formula represents 1 mole of the substance, but this 1 mole of copper sulfate is made up of 1 mole of copper, 1 mole of sulfur, and 4 moles of oxygen. The ratio is a certain ratio in the formula, and that's why writing an ionic formula is so important, because if you get it wrong, you do not get these ratios right, then this is also going to be wrong, and that means every other calculation that you now do after this is going to be wrong. Now the second thing you have to know is how to convert to moles if you know the mass. Now any calculation where you have to convert that involves mass, you have to calculate the molar mass of the substances involved. So if we're looking at copper sulfate, we see that we've already calculated the molar mass, so I'll transfer the answer here, and we see that the molar mass is equal to 159.62 grams per mole. So I went and calculate that first. Now I can go and do the equation. Now very important is when you get these equations, there are 2 things that you need to look at. One is what is known, what is given to you. So if we look at the equation, we see this is my known. This is what I know, it's given to me. So I know that. What is my unknown? My unknown is number of moles. This is my unknown. This is what I need to go calculate. So when you do dimensional analysis, you start it off by writing down your known. So I will write my known down, 281 grams of copper sulfate. So the first thing I do is write down what I know. I put that over 1 because I'm going to use dimensional analysis. I want it to be a fraction. So whatever I do is I take my known and I write my known at the top. Then I will go and multiply it, and when I multiply it, I need to work out what is going to be my dimensional fraction that I'm going to use. That fraction is going to come from the molar mass here, because this tells me that there is 159.62 grams of copper sulfate in 1 mole, because it's per mole. So I'm going to write that as a fraction. Now, How I write it, which one is at the top and which one is at the bottom, is determined by what is given to me. So if the given is mass and it's grams of copper sulfate, it means I have to have grams of copper sulfate at the bottom, because I need the grams of copper sulfate here to cancel out the grams of copper sulfate there. So how many grams of copper sulfate do I have? So I have in my molar mass, I have 159.62 grams of copper sulfate. What is my unknown? My unknown is number of moles, which means I want to know my mole of copper sulfate. The unknown is always going to be at the top. What you end up with at the top is what you are calculating, your unknown. So according to my molar mass, 1 mole of copper sulfate has a mass of 159.62 grams. By writing this fraction correctly, I would be able to use this to convert 281 grams of copper sulfate and find out how many moles that is. You simply put this into your calculator as a fraction if you want to, but you don't have to. You put this into your calculator and you get the answer. So you can use the fraction component on the Casio calculator to do this, or you can just simply see, oh, hang on, I have to take this because 281 times 1 is 281, and I have to divide it by 159.62. I go and do that on my calculator, and I see that my answer that I get is 1.7604, and so it carries on. So I need to figure out, so this would be mole of copper sulfate, but I need to figure out how many significant figures am I supposed to have. So that you will get from looking at your question. You were given this value as 3 significant figures, right? So this is 3 sig figures, and then your molar mass is 5 sig figures, right? So the rule is my answer must be in the least sig figure. So my least significant figures is 3. So I will write my answer as to 1, 2, 3 significant figures, which means I'm going to stop there. This 0 is not going to change anything with the 6. So my answer is going to be simply written as 1.76 mole of copper sulfate. Because grams of copper sulfate here cancels out grams of copper sulfate there, which means my final answer is mole of copper sulfate, and that's exactly my unknown. My unknown is number of moles of copper sulfate. Okay, so that's the calculation of the number of moles that you will find if the mass is given. Now the next type of calculation is calculating the mass if you are given the number of moles. Now again, same as before, we have mass. When mass is involved, I need to know my molar mass for copper sulfate. So I've calculated it, so we'll use the answer, but if you don't have it, you have to calculate it first, and we saw that it's 159.62 grams per mole of copper sulfate. So that's the molar mass of my copper sulfate. I have to calculate that first. Now, to calculate, same as before, to calculate the answer, I write down what is my known. What is known to me? 1.5 mole of copper sulfate. That's my known. I'll put it over 1 because I want to create a fraction. I'm then going to multiply it by creating a conversion factor again using my molar mass. So I have mole of copper sulfate at the top, which means I have to have mole of copper sulfate at the bottom. If that is at the top, this has to be at the bottom. According to this, 1 mole of copper sulfate is 159.62 grams of copper sulfate. Now if we go test this, we can see the question, the unknown, so remember this is my known. The unknown says calculate the mass. The mass is unknown. And when we do dimensional analysis, our unknown, which is mass is measured in grams, must always be at the top, and this is how it works out. If you write down your given and you make sure that mole of copper sulfate and mole of copper sulfate is opposite each other, if this one is at the top, then this one's at the bottom, so that mathematically they can cancel each other out. If you do that, you will always end up with the unknown at the top. Just remember, the unknown must always be at the top. My unknown is mass, and grams is mass. So again, I can take this and put it in my calculator as fractions, but it's both over 1, which means all I can see is I literally have to multiply this with that. I will multiply the two with each other, and I'm going to get an answer of 100. Sorry, let's just quickly do it here on the calculator. So we get an answer of 239.43 grams of copper sulfate. So let's just look at our significant figures. In my significant figures, I see that the given is 2 significant figures. My molar mass is 5, so my final answer should be in 2 significant figures. But because it's stoichiometry, it's possible that they will leave it as this, 239.43. But if you have to write this as 2 significant figures, you will simply make sure that you move this comma to the front, that you only have one value left. In other words, my comma is going to go 1, 2 forward. If I move my comma 2 forward, it's going to be 2.3943 times 10 to the power of -2, because I actually not -2, +2, plus 2, because I moved it forward, and I made a big number smaller, so it's a positive value. But my question says I need to give this as 2 significant figures, so 1, 2 takes me over there. I then go look, does this number influence this one, and I see it does. So that means my final answer should then be written as 2.4 times 10 to the power of 2 grams of copper sulfate. Grams of copper sulfate. So that is simply the basic calculations that you have to know for the test.